Our presenter today, Bill Murphy, has an extensive background in Michigan homegrown energy. He holds a degree in biology from Michigan State University. His career was in the Department of Natural Resources, working with scientific and technical staff, which gave him exposure to the state's extensive national resource issues. He has worked in the oil field for a year as well. He's written a dozen articles for Michigan History Magazine, which is where I became aware of the Michigan's homegrown energy. He has also authored several books that he says are basically travel guides for focusing on Michigan's natural and cultural history. A couple of announcements. Please, as usual, take out your cell phones right now and ensure they are silenced so as not to distract from today's presentation. Thank you. Also, welcome to the crowd joining via Zoom in the Haas virtual classroom. Special thanks to our course technicians, Gloria Goodwin and Mike Ranow, for supporting our hybrid modality. Please be aware that if you choose to keep your camera on, you are visible to all other Zoom participants. One housekeeping update, the bathrooms at the Knickerbocker Theater are once again available for our use. At the end of class, please feel free to push your chairs in. Questions and answers. Bill said he's open to having questions come in from the audience as he's presenting, but there will be a question answer series or time after the presentation. So with that, I'll turn the microphone and the camera over to Bill Murphy.
Thank you, Tom. Everybody can hear me well? All right, well, welcome to a discussion about Michigan's homegrown energy. And by that, I mean our history of coal mining, which not many people know about, and also crude oil production. I do want to thank Tom. He's the one who contacted me several months ago. He had read an article that I wrote in the Michigan History Magazine about crude oil drilling in Michigan, the history thereof, not a scientific discussion. And I also want to thank Amy and Hannah for their coordination work and also for getting me a parking permit for out here. So I know my car will be there when it's time to leave with no ticket attached. So it is important to keep in mind that today's discussion is not a scientific or technical discussion. I am not a scientist, haven't even played one on TV. It is a historical perspective of all, and it's a fascinating story. I'm not going to try to summarize it right now. It's a fascinating story, Michigan's coal mining and crude oil history. Tom mentioned the questions. I just wanted to say that if there was a particular discussion point or particular question that was really applicable right then and there at that moment, go ahead and ask. Just get my attention, throw something at me, whatever, but get my attention and let's ask it right then and there. It's not going to mess me up at all. In fact, rather than stand up here for an hour and talk, I would prefer a bit of back and forth. So there will be a Q&A, but don't feel that you have to hold all your questions for the very end. All right, we are all familiar with the term a bird's eye view when looking at something from above. This is not a bird's eye view. Imagine this is what I would call a worm's eye view, a very deeply burrowing worm, because this is the fascinating geology that underlies Michigan, which is why we are so rich in various underground resources, be it metallic, stone, limestone, sandstone. We have the largest limestone quarry in the world. A lot of people don't know that. Of course, copper, iron, and so on. But We also have in certain areas underground economically viable underground quantities of three fossil fuels, natural gas, which we're not going to talk a lot about today, but coal and, of course, crude oil or petroleum. So most Michiganders are well aware of our crude oil, petroleum activities in the state. As you drive around the countryside, you see the pump jacks, you see the tank batteries, the pipelines and so on. This is how widespread it is. The red is the natural gas primarily, all over lower Michigan, and that is the key. It seems incredible to me that literally at the Straits of Mackinac, there is a geologic divide separating the Canadian Shield and volcanic rock north of there from sedimentary rock south. The limestone, sandstone, and shale is critical to lower Michigan's oil and gas existence. We don't have the same geology in the UP. There have been, at last count, I believe, 14 wells drilled in the UP looking in areas where they thought maybe there we'll find something. Nothing thus far. So the UP gives us a lot of metallic wealth, but no oil or gas or certainly no coal. So the history of coal mining in Michigan is not so well known. The number, I did an article in the Michigan History magazine about this, and during and before that, and after that, talked to a lot of people, and people thought I was joking. I would talk about Michigan's coal mining history, and they literally thought I was joking, but it's not. The circular area right smack in the middle of the lower peninsula is the coal basin. And that's all because of what underlays it in that prior slide. There is coal throughout the basin. However, there's economically available coal only in the eastern portion from Bay City down to about Jackson. A couple of reasons for that. One is the bedrock in the north and the west is much deeper in those areas than in the east. And there is much more glacial drift. All that dirt, stone, sand, gravel, whatever that the glaciers left behind as they melted, the glacial drift is much deeper on the west side, to the extent that in the Jackson area, most coal is well under 100 feet, maybe 100 feet at the most. Deeper further north near Saginaw Bay City. In the north and the west, it's about 900 feet deep. So it's there, but trying to get to it would be like spending $1,000 to get $10 worth of coal. It's just not economically viable to do it. A bit about coal. So to make sure I'm not going to make a mistake and leave anything out, I'm going to read this. Coal is a combustible, carbonaceous, organic, sedimentary rock. We all knew that, right? It is comprised primarily of carbon and a few hydrocarbons. A few other elements are involved, including oxygen, sulfur, and hydrogen. The life story of coal is fascinating, and it would make a very, very long movie. Coal comes primarily from big stuff, dead big stuff like giant trees. Southern Michigan was covered for millions of years by swamps, tropical swamps, like the slide depicts. This was from the Carbonaceous period, which is 300 million years ago, give or take a few million. And over literally countless, not millennia, but millions of years, these big trees and all the other plant life and other life grew and died and grew and died and accumulated as peat. Lo and behold, after millions of years, oceans moved into the area, covered the area again for millions of years. Under the oceans, because of the precipitate, sandstone, limestone, shale formed on top of the peat, oftentimes 100 feet or more of the bedrock. So underneath the ocean, underneath this thick layer of bedrock, is the peat still there. And with millions of years of time, pressure, and heat, metamorphosis took place. And that's a key word because it literally changed physically the peat to coal. And you know, there it sat for a very long time, and the oceans obviously gradually moved off, and Michigan moved to its current location, and the years later we found the coal. So the amount of peat in places like West Virginia, Wyoming, Pennsylvania was hundreds of feet thick. In Michigan, it was about probably 60 feet thick, the peat, when it was covered by the ocean and the bedrock. 15 feet of peat, after it goes through all those millions of years of metamorphosis, will create about 1 foot of coal. So it takes a lot of peat. You imagine, I don't know if any of you have ever been out to Gillette, Wyoming, to that huge coal quarry, hundreds upon hundreds of feet of nothing but coal. I've often wondered what that looked like millions of years ago. So that's how it's formed in a very quick. There are 4 types of coal, just very quickly. And the peat on this slide that I'm showing should reach up to the ceiling in order to be really to scale, to make as much coal as is being shown there. After just a few million years, you get lignite or brown coal, very poor quality. It's got a lot of moisture in it, a lot of organic material, a lot of sulfur. You can burn it. It's certainly better than peat. I was in Ireland a few years ago watching a number of farmers burning peat. It's really quite fascinating that it's kept them warm for millennia because it's really poor quality. They would love if it had been converted to lignite. And lignite, not much use for it. A few more million years, you get sub-bituminous coal. A fair amount of Michigan's coal was sub. More time, heat, and pressure, you get bituminous. That's the common coal we're all familiar with, the black coal that's used in industry and what we would all recognize. Anthracite is much rarer. There's a place in central Pennsylvania where it's mined. It's a shiny, glossy, very, very hard coal, very pure, also very high in BTU value. A lot of institutions, apartment buildings, homes, government offices, buildings like this 100 years ago or so would have been warmed by anthracite coal because it's clean, very little ash development, very little sulfur in the air, so the air wasn't as dirty. So,
I have a quick question.
yes.
when you talk about the ocean covering the state of Michigan, was that really the glacier melt or was it salt water?
No, this predated the glacier by millions of years. It was a saltwater ocean that literally covered much of central North America for a very long time.
Mhm.
And this long predates any glacial activity.
You know, okay.
There were glaciers at the poles. There were glaciers at the poles, and there were time periods throughout history where the glaciers were huge, and when they built up, they used up water so that water in the rest of the world went down. Okay, so you get these shallow areas with swampy areas like in the Carboniferous period. And then another epoch comes along and the climate is warmer. It will melt those glaciers at the poles, which will raise the ocean levels. The ocean levels could go up and down by several hundred feet. And so that's probably what happened. Yeah. And I had a question. During the Carboniferous period is when you're talking about the coal was formed, but the Waverly Stone that we have in Holland was also formed during the Carboniferous period. So that was probably underwater. Was the center of Michigan a little higher than what the edges were?
The Michigan, the geology in Michigan is bowl shaped. So the water would have been deeper. The ocean would have been deeper over the
middle.
Central,
Yeah.
over the middle.
Oh.
And Tom, to your point also, I should have been more specific in saying that it was not the last round of glaciers that we're all familiar with from 10,000 years ago that caused this. This all occurred millions, hundreds of millions of years before the most recent glacier that left all the glacial drift that we're so familiar with.
Glacial drift.
The dirt, the rocks, the clay, the sand, the gravel that literally fell out of the glacier as it melted.
Yeah. It's just things that were being carried by.
Yes. And it was very, very substantial. I mean, the hills of northern Michigan were not formed by plate tectonics. They were formed by all the glacial drift and some bulldozing and other things, but they were formed by the glaciers, not like, the Rockies or the Appalachians.
Or volcanoes.
Or whatever, yes.
Yeah.
Yeah.
Well, I had one more question too. You hear a lot about clean coal these days. Is that coal that's from the you had the chart, you had 3 or 4 different kinds of coal. I can't remember what the first one was.
Yeah, nobody would be burning lignite or brown coal. Clean coal, there was a time when sub-bituminous coal was burned because everybody burned coal, everybody needed coal. And if you had even poor quality sub coal, you could sell it.
Sure.
The power plants, the steam locomotives, you name it, all the places that burned coal.
Yeah.
Anthracite was the best, but it was really, really too expensive for most people. Yeah, so clean coal would be a focus. Even within the same mine, there's going to be some coal that's a higher quality, higher BTU, less sulfur content, less ash left when it burns. And, the coal from that seam will sell at a bit higher to more preferred customers that want it.
Okay, thank you.
Oh, you bet. So Michigan's coal story had 3 very distinct chapters. In chapter 1, coal, keep in mind that Michigan was a 99% wilderness back in the 1830s. And I'm going to say 1930s at some point, so forgive me up front. We're talking 1830s. Michigan was virtual pure wilderness. The first coal, and it was settled from the south, from the Chicago, the old South Trail, north and west from Detroit. Coal was found first in western Jackson County near Spring Arbor. It was outcropping. There were a few places in Michigan, in southern Michigan, where there were outcroppings of coal. Not a lot. There were actually 4 counties where there were some outcropping that resulted in very early mining. And I use that term loosely because homesteaders were buying this land in the mid-1830s in southern Michigan. And lo and behold, a few of them in Jackson County, Eaton County, Ingham County, and Shiawassee County found this. Wonderful, good luck for them. So the coal back then was not maybe as valuable as you think, because a couple of reasons. Number one, everybody was falling trees. You had the firewood was plentiful and it was free. Nobody really needed coal. The average person certainly did not need coal. They got along just fine without it. I read somewhere years ago that the BTU value of some hardwoods, some of the oaks and others, was probably the equal of this poor coal. So it wasn't, like people weren't dancing in the streets, which did not exist. So a few lucky landowners began digging up the coal for their own use and also selling it locally to anybody that wanted it. But not many people did. And make sure I got my date right, in 1840, after 5 years of coal mining, state geologist Douglas Houghton estimated that about 1,500 bushels, not tons, bushels of coal had been mined in Jackson County for local use. So it was not a big deal, but it was the beginning of something very big. Every village back in the day had a blacksmith. The blacksmith did want coal, and it was important that in southern Michigan, as villages were starting to form circa 1840, that there was some coal available locally. Otherwise, it had to be shipped in from out of state at an incredible cost from West Virginia, Pennsylvania. There were no roads back then to speak of. And that was another reason that coal was a local affair, a local village affair. The landowner and a mile or two away, the village blacksmith. There were no roads to transport it anywhere. And the very rough trails, even the occasional plank road, did not suffice because Michigan's coal, especially in the South, was poor quality. And even in later years, when they did try to transport it over roads, it crumbled. And you ended up with a load of essentially dust, crumbly dust. It was very poor quality. So it was a local affair. So at that time, there were two types of coal mining. From 1835, 1840, 1845, things were changing rapidly in southern Michigan, very rapidly. So there was, by 1840s, low 40s, there was a regional demand for coal. In the 1843, 1844, the Michigan Central Railroad connected Jackson and Detroit. Suddenly, there was a market for this coal. Not huge, but there was a market. So it went from surface mining by a few locals to what were called slope mines. And you started at the surface where there was an outcrop, and you dug down. You followed the seam of coal down, and enough so that you needed mules to get it back up. And this became the primary type of mining. 1845, 1850, 1855, actually all the way up to the Civil War. It was these slope mines where they followed seams of coal down at an angle. Again, Michigan's coal in that period was Jackson, Eaton, Ingham, and Shiawassee. Now, Detroit was growing. The other very, very big thing that happened in the mid and late 1840s into the 1850s was railroads. Railroads were spreading all across southern Michigan. Those locomotives, they weren't this impressive, but those locomotives needed two things. They needed water and they needed coal. They needed a lot of coal nearby. So Michigan coal was burned in a lot of those early locomotives. Just want to glance occasionally, make sure I'm not missing something that was really, you would just love to hear about. But so Michigan coal went to Detroit and was burned in here. In the 1850s, mining became big in Michigan. The UP mines were starting up and doing incredibly well. Coal mining was really on the upswing. The legislature enacted several laws regulating the whole mining business. One of them required annual reports of output. How many tons of copper did you mine? How many tons of coal did you mine? So the first report was filed in 1860. And in that year, Michigan miners from those slope mines reported 2,320 tons of coal. That's a pretty small amount. There was no regulatory agency. There was no enforcement inspector going around to these mines checking. I personally highly suspect that was a rather low number. It was the first year for the required reports. A lot of people probably didn't know about it. But 2,300 tons roughly in 1860. So after the Civil War, settlement in Michigan and development increased dramatically. And coal mining became much more important, much larger, and much more professional. Still in that same southern Michigan area, though. The demand for coal meant that the privateer, the guy digging coal on his own property, or these small slope mine operators, they were history. They could not produce enough coal that the market demanded. It required professionals. It required companies, large companies with a lot of capital who could hire the best geologists and engineers and pay their workers well. This is a schematic of a well near Jackson. And just some important things to put in scale. The black, on the bottom, the black line there, that's the coal. It was only about 3 feet thick. And the other thing about those seams, this shows it just going in one direction as a surface of the picture, but they went everywhere. And once you were underground to the seams, miners just followed them wherever they went. They went up, down, sideways, left, right. The miners just followed them wherever they went. Two other important things here. On the very top, there was only 10 feet of drift. That was very easy to dig down to the bedrock, scrape that dirt away on the top and get down to the bedrock, which was sandstone and shale. There was 80 feet of sandstone and shale down to the coal. So the only way to get down to it was to drill or to dig a shaft right straight down and turn it into what was at that point in time a very typical kind of mine. You had elevators that went up and down the shaft that took the workers down and brought the material up. And this type of mine was the norm in the period from the end of the Civil War, 1865, to the early 1990s. I'm sorry, 1890s. And most mines in the Jackson area were like this. They were about 50 to 100 feet deep. They were not fun places to work. If the seam was only 4 feet, that's what was mined. A miner's day was often spent laying on their belly or on their back in the mud because groundwater intruded into these mines. They laid on their belly or back and hacked away at the coal in front of them. The average worker mined about 2.5 tons per day. With this kind of mine, by 1870, they were producing, Michigan was producing a bit over 28,000 tons per year. And by 10 years later, 1880, Michigan was producing a bit over 100,000 tons of coal per year. And the number of the number of mines peaked in 1880 at 160. That included, again, all in the South, every kind of mine, 160 of them. But from 1860 to 1880, it went from 2,000 to 3,000 tons to 100,000 in that period. And this is another Jackson County mine. This was in the 1870s and 80s. Jackson County became a very big coal mining industrial county. It was their largest non-farm employing business was coal mining. And the various jobs connected with it, not just the miners, but the jobs connected with it. The average miner made about $2.40 a day, laying on their back and their stomach in the mud. So something big happened in circa 1890. Southern Michigan ran out of coal. The mines that we're talking about here literally could not find coal. The seams in Michigan, they went for maybe 10 yards or 100 yards and they would just end. This one over here went for 20, 30 yards and just ended. By 1890 or so, they were literally running out of coal in the southern Michigan. And there was another huge demand for coal because what was happening circa 1890, we were building coal burning power plants all over the place. They wanted a ready supply of coal, which Michigan, southern Michigan was no longer able to provide. So we enter chapter 3, a very, very different situation. So coal engineers knew that in the northern part of the basin, in the Saginaw Bay City area, Saginaw Valley, that there was coal, because in that area they were drilling a lot of mineral wells, brine wells, and water wells, and they would hit coal. But the thing is, it was 200 feet or more deep and under a lot of bedrock. It was there, it was tempting, but the market just did not create the financial incentive to go after it. So the business people, the financial folks thought that, okay, now is the time to invest money in northern Saginaw Valley for the coal that we know is down there. And they did, and everything changed. Instead of the very insignificant mines in the south, there were mines like this cropping up in Bay County, Saginaw County, Tuscola County, Huron, northernmost Flint, Genesee County, and they were doing remarkably well. The coal they found a couple of 100 feet underground was a significantly higher, cleaner coal, burned with a higher BTU value. It justified this type of investment. Some numbers, and this was near Bay City. I mean, you can imagine a mine like that cropping up when in the past they were just digging small holes in the ground to get coal. It had gone a long way. So in the 1880s, we were doing about 100,000 tons of coal per year. From about 1895 to 1897, these kinds of wells, these kinds of mines were being built. In 97, it jumped up to 250,000 tons per year. In 99, it was 600,000 tons per year. In 1900, 1 year later, it was 800,000 tons per year. And by the way, of that 800,000, 23,000 came from the Jackson area still, south. I did the math, that's 2% of the coal in Michigan came from the South Basin. 98% was coming from the Bay City, Saginaw Basin. A year later, production jumped up to 1,250,000 tons. It was a big business. Production peaked in 1907. In that year, and I counted them, 3,971 miners produced 2,036,000 tons of coal. It was a very big deal. It meant a lot. It meant a lot to, I've always wondered, probably no way to know that about that time, suddenly factories were moving to the Saginaw area, plants that later became connected with General Motors. You know, did they go there because of the proximity of the coal? I don't know, but I can imagine boardrooms talking about that, that let's build our factory in Saginaw because they got lots of coal. And it's good coal. It's hot, burning, clean coal. So it peaked in 1907. And you can see the lower graph. There's a gradual downslope. It never did recover. The value hit its peak in 1922 at $5.05 per ton. That was primarily because of a series of coal miner strikes that was taking place. Coal mining was a horribly dangerous, difficult job. In the early 1920s, there were a lot of big strikes across the country. Michigan was a small time player, but our miners went out as well. So after 1907, the peak, even the northern basin was beginning to run out of coal. As you might expect, there was a little bit of a blip during World War I and II, but in Michigan, it was insignificant. This particular photo from the Detroit Free Press in April of '45 shows a small strip mine just east of Lansing, about 10 miles. And it had been in operation for quite some time. It was one of there was another small strip mine near Owasso, Corunna, and a few others, I think one near Grand Ledge. The interesting story about this one that is worth telling, they closed many, many years ago, but in 1975, during the oil embargo, they reopened this strip mine for several months. In 1975, they dug coal out of it, sold it to the Lansing Board of Water and Light to be burned for the power. And after several months, they closed it. And in talking to people later, there was allegations that the landowner did that because there was coal there for the selling, but also he owned the land around it that he wanted to subdivide, and he wanted to make that a lake. So by digging out the coal, he accomplished two things. He made his basin for the lake and of course, used a valuable resource for a bit. The last coal mine in Michigan, the last big true coal mine in Michigan was the Swan Creek mine near St. Charles, Saginaw County. It closed in 1952, and that's the end of our coal history. This picture tells a lot. Obviously, the dirty conditions, but it was not a young man's future. You know, maybe in 1900, there may have been people that when they got out of high school, they went into the mines. But surely after 1920, they weren't. These old guys were at the end of their career, and it reflects the sorry state of the industry. But that was the last coal mine in Michigan. In the Saginaw area in particular, there are a lot of remnants of mines. The Shiawassee Refuge, there are a couple in the refuge that you can walk back and see the remnants. And St. Charles actually has kind of like a museum run by the school system where there are old mining buildings and such. So very interesting to go see it. One of the, I'm going to go through this quickly, and so it's second a news article. There were no regulations overseeing coal mining. So when a coal mine went out of business, very often they walked away. Oftentimes the tunnels and the shafts were left empty. Some of the larger companies bulldozed their buildings down into the shaft as the means of plugging them. But of course, that wood and whatever rotted over the decades. And there are numerous places, especially Saginaw, where there are houses, malls, parking lots, roads built on top of mines that nobody had a clue were there. So fairly often, a backyard will suddenly just cave in. And there's an old coal mine that finally collapsed after all those decades. There is a federal agency the federal reclamation program that has spent a bit over $5 million in Michigan in recent decades, plugging abandoned coal mines. Of course, the first problem is finding them because they're not always on maps. They're not on township zoning maps and so on. But the Reclamation Agency did plug 71 vertical mine shafts in Michigan over the last 30 years or so. So time and money is being invested in that. Very recently, about 2 years ago, the MDOT doing some work on I-94 near Jackson. They had the experience of cave-in, right, where I-94 was being worked on. So it's part of our history. So as coal story was coming to an end, another energy source was causing great excitement. Crude oil, black gold, Texas tea. And oil quickly became the new king of the hill for Michigan energy. Oil is like coal, except instead of big trees by the countless trillions and other plants and millions of years, oil more often formed under oceans. It was the precipitate, the plankton, zooplankton, phytoplankton, bacteria, tiny animals by the countless trillions over millions of years that settled down. All those organisms became the new material or the material for the creation of crude oil. After those three things happened: time, pressure, and heat. Because while these dead critters are piling up on the bottom of the ocean, you were getting the same effect of the buildup of sandstone, limestone, shale, whatever on top, creating pressure, creating heat. And the organisms were slowly converted to crude oil. So for a long time, it was known that there were surface seepage pits for crude oil and tar beds in the lower Great Lakes area. But for a long time, they were viewed as worthless. Then, circa 1860 or so, a couple of things happened. The availability of whale oil, camphor, and other varieties of oils, illumination after sunset was the driving factor. It wasn't big motors, it wasn't, cars, whatever. It was plain and simply illumination. And we were running out of things like whale oil and other fuels that were used in bowls and lanterns. A Canadian scientist determined in 1848 that coal oil and the material that he called kerosene could be derived from coal. In 1860, an American scientist determined that, hey, kerosene, a better grade of kerosene, can be derived from crude oil, from petroleum, from all those that terrible pits of bubbling tar that everyone thought was such a bad thing, suddenly became very valuable because you could convert that quite readily into kerosene, for which there was a huge, huge market. So and also we were of course becoming much more mechanical. So the other uses they found for petroleum, this crude oil, was for lubrication for the many different machines that were being put into place, that were replacing flesh and blood horsepower. So by the mid-19th century, it became financially okay or smart to look for crude oil, look for this tar, this petroleum, other than surface pits. In other words, that meant drilling underground. It became financially wise to drill underground to look for crude oil. The market was there. Now we had to find the product. In the first biennial report of the Geological Survey of Michigan, published in 1860, it referred to information obtained from various deep borings of water and mineral wells. The report noted the possibility of crude oil in lower Michigan, especially in the Port Huron area, because 2 years earlier, an oil well, a very highly productive oil well, was drilled just across the river a few miles in Ontario. And that was, in fact, the first true oil well. It wasn't the one in Titusville, Pennsylvania. It was the one in Ontario, across from Port Huron. So with all these various wells that were being drilled for water and brine, enough was known of the local geology that geologists could confirm with pretty good likelihood that there is oil under St. Clair County. And the first documented oil well in Michigan was drilled in 1863, just north of Port Huron. And it was a success. By the end of 2 years, a dozen more wells were drilled. They were getting between 30 and 40 barrels per day. Petroleum barrels, by the way, are 42 gallons, not your typical 55-gallon barrel. For whatever reason, petroleum is 42-gallon barrels. So a number of shallow wells were dug north of Port Huron and around Port Huron by the end of 1865. These were all 1,000 feet or less, but they hit oil. And Michigan's first oil boom resulted in as this was going on, land in that area you could buy from the government for, I think, $2.25 an acre. Land in that area was selling for $1,000 an acre. And the value of crude oil at that time was $11 per barrel, which is like $200 today. It was a boom. It was boom times. But booms always come to an end, whether it's metallic or liquid, and this did. The reason is because all across America, literally, they're all across North America, they were looking for oil. And suddenly the supply far outstripped the demand, and the value just plummeted. So it wasn't until 20 years later that Michigan's crude oil business was able to take off again in St. Clair County. That was the birthplace. And this was for two reasons: the greatly increasing population and industrialization. That resulted in much more demand for lubrication for mechanical equipment. You know, we didn't have internal combustion engines, but we had a lot of equipment that needed lubricating. A lot of equipment. Every one of those locomotives had to be oiled every day, and everything else you can imagine. And they were still providing the market. Natural gas had not yet been sent to the cities. They were still providing the nighttime illumination market. They were making kerosene in great volume. So by 1900, oil was being found pretty much all over lower Michigan. That was really a heyday period from like 1886, let's say, to the early 1900s. There were, just in the Port Huron greater area, they estimate at least 400 wells were drilled. The lifespan of all of those wells was quite short. Every one of those 400 plus wells was unsafely abandoned, causing serious problems down the road. The heyday really did come with a large price tag for people living in the area. Groundwater aquifers were contaminated. Brine came up and mingled with fresh water. Oil came up onto the surface and literally destroyed streams and creeks and little ponds and what have you. It was totally unregulated. And at the same time, the great timber harvest, and I use that rather loosely, was taking place in Michigan, also completely 100% unregulated. And Michigan was being deforested in about 30 years. It became deforested. And all across lower Michigan, countless wells are being drilled and abandoned, whether they were a dry hole or not. After a few years, they were abandoned. So in 1912, the Geological and Biological Survey once again said, hey, we really need some regulation here. 15 years later, in 1927, the Michigan legislature did enact the first oil well regulation. It was a law, Act 65 of 1927. It designated the director of the Department of Conservation as what was called the supervisor of wells. And it required certain, by today's standards, it was obviously very weak, but it required certain things, that certain standards be in place for the drilling of wells, certain standards be in place for the disposal of brine and the loss of petroleum and all that. And importantly, standards for the plugging of abandoned wells. And they required a permit. So permit number one was issued in September of 1927 for a well drilled in Mason County near Ludington. That year, a total of 16 permits were issued in 1927. And I meant to refer to that one a few minutes ago. Sorry about that, and missed a slide. But going back to that, I want to show this once again, because by the early 1900s, certainly by 1927, this is what the oil industry looked like in lower Michigan. They were, in fact, drilling wells all over lower Michigan, with the exception of 2 or 3 counties where geologically there was not crude oil. Emmett County, as I recall, was one, and way up the northwest. And there was 1 or 2 others where I think they did not find it. But they were finding oil. And when you find oil, pretty much you're going to find gas nearby, all over. And you can see this area over here, Ottawa County area, Allegan County, was a very big oil producing area. So I wanted to show this for a couple of reasons. Again, partly environmentally, we do, when you drill a well, and one of the things I remember, I spent an entire year as a kid, 1920, working in the oil fields. And I had the opportunity to drill a well, literally from a bare field to a functioning oil well. It was fascinating to see how it was done up close like that. So almost always we have to drill through our precious drinking water, our precious groundwater. And this doesn't show it, but very, very often in Michigan, because of those old seas, there are pockets of brine below there as well, brine, salt water. That's why Muskegon and Midland and other chemical companies, chemical towns are here because of that brine. That's where they get the chemicals from. But you have to go through the drinking water. You have to go through a lot of rock, of course, to get down to the oil. Back 100+ years ago, there would have been just one tube that went all the way down. After the regulations, there's a system called casings, and these are concentric tubes. Very often in the upper portion and through the water, there could be 4 different casings, and in the very inside is the production tube to protect the water. And very often the annular space, the space between the concentric tubes, is filled with cement, with concrete, to make sure that this is under great pressure, and to make sure that nothing comes up from below. You know, in 150 years ago, every well was celebrated because there was a huge geyser. We obviously don't want that. We want to block it down there so that that oil under great pressure doesn't just shoot up. There's almost always natural gas by the oil. That's critical, not only because it has value, but it provides oil. We hear the terms pools of oil, reservoirs of oil. That's just incorrect. Oil exists as tiny, tiny, tiny droplets within the pores of hard rock. It's not a liquid by any means. So when you puncture that rock, starting in 1932 in Isabella County, Michigan, somebody had the great idea, well, what if we pump acid, hydrochloric acid, down into that solid hard rock to kind of make, under pressure, to kind of make little cracks in it. And it worked wonderfully well. They were able to get the oil to flow much more freely. It's still not liquid, but it was able to flow more freely. But what they found out was you do not want to depressurize that zone, because the natural gas pressure is helping push, if that's not the right word really, but it's helping to force the oil droplets out of the rocks and up the pipe. So another comment kind of off the mark here, that well, let me do this. So oil exploration spread all over Michigan. This is near Rosebush, south of Mount Pleasant. And you might wonder, you know, do I want this in my backyard, on my farm? And the answer is yes, for 2 reasons. One, I didn't know until I actually helped do it. But one is royalties. If you own the mineral rights under your land, you get royalties. Now, back in these days, there were a lot of shysters buying up mineral rights for a penny on the dollar. And the farmer was stuck with this and did not get a penny for it, because they no longer own the oil rights, the mineral rights. But the other thing, and I believe every operator did it, and I did it. I personally laid the gas line. When a well is drilled on private property, generally a farm, a gas line is run from the wellhead to your house. So you got free natural gas as long as there's oil being produced in that oil well, which is a pretty good deal. Oh, I see I'm going a bit late. So in 39, another law was passed to greatly tighten the regulations. There were a lot of pretty bad stuff happening. This is a bad picture of a tank battery exploding. There were still a lot of problems. That in 1939, a new Act 61, which my time in the DNR was the act that was in place that we used to enforce the oil regulations. That all changed actually about 30 years ago now, but the DNR director is no longer the supervisor of wells. Through actions by various governors, the program is now run in the Department of Environment, Great Lakes and Energy, in the Geological Resources Management Division. So it's still there. There's still very strict laws that have to be followed, and the relationship between DNR, DEQ, EGLE now, and the oil industry went from very rough for a lot of years to really very cooperative. They have the money to do it right for the most part, and they don't want the bad name. You know, if they have an oil spill on the Al Sabo River, you know, forget it. You're going to be mud the rest of your existence. So they do work hard. I wanted to talk about this very quickly. The red area, the Niagaran Formation, both oil and gas. It was known back in the 50s that there was a lot of oil and gas under that Gaylord area. But where that red is also where the Pigeon River Country State Forest is. They call it the Big Wild. It's the largest wild place in lower Michigan. A lot of people love it. It's a beautiful place. If you've never been there, they call it the Big Wild for a reason. That's where the elk are in Michigan. There was tremendous Shell and some other oil companies held the rights, a lease. They held the leases. The state of Michigan held the mineral rights on behalf of all of us. But Shell, many, many years earlier, had received leases from the state to drill in that area. It went all the way to the Supreme Court. An agreement was worked out, which resulted in 1976 of what's called the Michigan Natural Resources Trust Fund. One of the top 5 best things to ever happen in Michigan, in my opinion. That trust fund uses money from the public's resources, the royalties from allowing drilling and extraction of gas and oil from that region, goes into this fund, and then it is used for to help the public, help the environment, and provide outdoor recreation activities for the general public. It is absolutely future-based. Every county in Michigan has received numerous grants. They're not. I'm not sure what the right word is, but you don't pay it back. I mean, you get the money, and you can use it for river access, a park, whatever you want. For Ottawa, this is Rosie Mound. I don't know if any of you have ever been there. This is a piece of land on Lake Michigan that Ottawa County bought for the public for the future using Michigan Natural Resources Trust Fund dollars. Did not cost U.S. taxpayers here a penny. It's the first in the nation. It's still the only one in the nation that to the extent of the things it does. So there are, I'm going to skip over some of this. Overall, somewhere between 48,000 and 52,000 wells of all types have been drilled in Michigan. Most of those we don't know because they were abandoned 100 years ago. 15,000 of those were oil wells. Of that 15,000 oil wells, approximately 4,200 are still pumping. However, 65% of that 4,200 are stripper wells. That means they produce less than 10 barrels per day. Those are the wells that Shell Oil, and you name it, every big oil company sells to me. I want to start a little local oil company, but I don't have much money. I don't have much resources. I can buy 100 stripper wells and make a few bucks a month. And of course, when they run dry, I walk away and they're abandoned. They become orphan wells, and that happens. The last thing is orphan wells. There are known 449 abandoned orphan wells in Michigan. There is a fund, a state fund of about 25, I'm sorry, let me back up. There is a state fund, the Orphan Well Fund, with money used to try to plug those 449 wells. Just a couple of years ago, the Infrastructures and Jobs Act of 2021 infused $25 million into Michigan's abandoned well program. So we now have our own state law and money, and 25 million in federal dollars now to properly plug these 449 abandoned orphan wells for which no culpable party exists. The state has no idea who abandoned those, or if they do know, it's someone like me that has no money, so I can't afford it. So that's why they're called orphan wells. So I apologize for going over. We're at the cusp of a new period. Michigan's natural gas and oil will continue to play a big role in all of our lives for many years to come. It's not going away anytime soon. We will be using it for years and years and years. But we're obviously, times are changing. Our great grandchildren, we'll see a very different world. So anyway, thank you for your presence, and any questions at all, I'd be happy to answer.
I have one question. Is there consideration of fracking oil out of Michigan?
There's the, in the technical term just escaped my mind, that there is one bearing area in Michigan in north central lower where fracking was tried. Michigan does not have the geology to make fracking a feasible or viable thing. We're talking wells that are much deeper into a very different strata than what we have here in Michigan. It was tried, and it has happened on a few wells. It is controversial when it happens because not because of the acid, which we've been using acid for 90 years. When I saw the great big truck of acid pull up to this well that I helped drill, I found it just amazing that all of that acid was being shot down under great pressure, 5,000 feet into the earth, into this stone. So that's been going on. That's very controlled. There's no waste that results or that's generated. With the fracking that you're talking about, there is waste involved in huge quantities of water, chemically treated water, that is shot down and then brought back up. So, but it is not a common practice in Michigan. Unless they find a totally new, unknown bearing strata that, we just don't know about yet. But no, it has not played a large role in Michigan.
You have a question, Susan?
Do you know what the history of the wells that are along the Grand River floodplain just west of Grand Rapids?
I'm
There's
sorry.
there's
Yeah.
little wells all along there. You can see them in the winter. They're usually underwater.
I do not know the history of them. I would imagine that they're quite old. I mean, they're not going to permit those in the 1990s or something, but there is a permitting process and there are technical standards, going back 1950s or whatever, even further back. There's a process, there are standards, but it's just like filling a wetland. People say, well, there's a wetland law, you can't fill a wetland. Well, yeah, you can. All you need to do is get a permit. And absent certain very unique or endangered plants or something, it's quite likely that you will get the permit. So if there was nothing about those wells 75 years ago that said this exists, therefore you cannot drill there, they would have gotten the permit. And of course, presumably, we know who they belong to, so that, and we also have, and I've got to say this with all honesty, we have in Michigan a very highly trained, capable staff that works now in EGLE, Environment, Great Lakes and Energy, that they work there because they give a damn. They care a lot. They've got science degrees. They could be earning a whole lot more money working for Dow or whatever. And I don't say that negatively, but they work for the DNR or EGLE because that's their passion, and they will make decisions. They're bound by the law. If the law doesn't give them the authority to do this, then they can't do it. If the law did not give them the authority to deny those permits for those wells, they had no choice but to issue them and then follow up on frequent inspections.
When I was a teenager, about in 1943, here in Holland, then with the Overijssel field, I can remember they would sell part of the well before they would, like a 1/16 or so before they would start, and then you could buy into a particular well.
Yes, I have heard of that, and I imagine those wells are probably highly represented in the orphan wells, because for one thing, you're talking people like you and I that do not have a lot of money. Abandoning a well properly is very expensive, and most people that buy into that, they don't have the money. They're making, I mean, I'm just guessing $100 a month or whatever. They're making pretty small money, and most of those individual people like us cannot come up with $100,000 or whatever to properly abandon a 5,000-foot deep oil well.
I have a curiosity question. If you know the answer, historically, the Michigan, both not gas, oil and coal, how did its quality compare to Kentucky or Oklahoma or something like that? Do you know?
Well, as far as the coal, our coal was, we could never compete on the open market, even if we had a lot of coal, because it was poorer quality. A lot of it was sub-bituminous, but before I wrote an article in the Michigan History magazine a couple of years about Michigan's coal history. And one of the things I came across frequently in like Michigan State University geologic reports and state reports was, and they use the word crumbly, how uniquely crumbly coal from Michigan was. And if you're going down a bumpy road with it, 50 miles, by the time you got there, it was pebbly. It could not withstand transportation. And a lot of it, even the good coal up near Saginaw, would not hold a candle to the really good hard coal from West Virginia, Wyoming, for sure. That Wyoming coal is very good coal. So gas and oil, no problem. We had, it was of the same quality, physically as anywhere else, but our coal, of course, we weren't trying to be a national actor with the coal. We were happy selling it to the local towns nearby.
Other questions? Well, we want to thank you, Bill, for a very interesting presentation here.
But Tom, there will be a test.
Uh-oh, I'm out of here.
Thank you all for coming.